This is lesson 113 in Algebra 2, and the name of this lesson is called Logarithms and Anti-Logarithms. So this whole idea of logarithms and anti-logarithms are probably pretty new. I don't know if you did any of this in Algebra 1, but I don't think you did. This section is interesting. It only is a short section on logarithms. Yet when you get into college algebra or intermediate algebra, there's a whole chapter on it. So obviously we're just going to hit the basics of it. And I'm just going to have to remember not to go into a lot of detail here because the book doesn't, and you're not expected to know all the detail. But let me go over 3 rules of exponents with you. And I'll relate exponents to logarithms in a minute. And let's not worry about anti-logarithms right now. Let's just talk about logarithms. Alright, so if we have 3 to the 5th times 3 to the 6th, in order to multiply those, the base numbers have to be the same. Okay, it doesn't matter what the exponents are as long as the base numbers are the same. And then that equals the base number, and we add the exponents. Okay, so that's one of the rules that you know. Another rule you know is if you have 3 to the 6th over 3 to the 5th, again the base numbers have to be the same, and that equals 3 to the 6th minus 5. So multiplication, you add, division, you subtract exponents, and then we've got the power rule where I have 3 to the 5th to the 6th power, and that equals 3 to the 5 times 6, which is 3 to the 30th power there. Okay, so when you multiply multiply numbers with exponents, you just add the exponents. When you divide, you just subtract the exponents. And when you have 3 to the 5th to the 6th power, you multiply the exponents. Okay, now the reason I say that is because with logarithms the rule is the same. Alright, so what the heck is a logarithm? A logarithm is just another word for exponent. So if I have an exponent and I want to combine some things, a logarithm is just another name for that exponent. Alright, so let me show you the relationship between what's called exponential form. So we've got exponential form and logarithmic form. Okay, so you've got exponential form and logarithmic form. Exponential form is what you're used to. 10 squared equals 100. That's exponential form. You have it written in a form where there's an exponent. To write this exact same thing in what's called logarithmic form, you write the word log, we put a 10 down here, we write 100, and we say 2. Okay, so let's read these out loud. 10 to the 2nd power equals 100. 10 times 10 equals 100. This says the log with base 10 of 100 is 2, meaning 10, what is the exponent we put on 10 to give us 100? Okay, so we use logarithms mainly when we don't know what the exponent is. So for example, if we had 10 to the x equals 100, this says what is the exponent we're going to put on 10 to give us 100? This says the same thing, log 10 100 equals x. So what exponent can I put on this base number here, which this is the base, that will give me 100? It would be the same as me saying, what is 5 to give me 25? What number can I put on 5 to give me 25? 2. Let's say that I put 125. What number can I put on 5 to give me 125? 3. 5 and we'll write this as an exponential form here. Okay? So two ways of writing the same thing. One is exponential form and one is logarithmic form. Okay? So, I'm just trying to focus on not going into too much detail on this stuff yet, just kind of giving you the basis of that. So one of the things is you need to be able to convert going back and forth like I just did. All right? We have actually two different kinds of logarithms. The process of solving is the exact same. It doesn't really matter, but there's two processes. One is called a common log, and it's written L-O-G, and you should have a button on your calculator that says L-O-G. Then we have what is called a natural log, and its symbol is Ln for natural. Okay, so one is an LOG and one is an LN. Alright, and you should have an LN button on your calculator too. Alright, so an LOG always has as its base on your calculator of a 10. Always. Okay? Now when we're doing things by hand, I can write like log, like I did earlier, 5 of 125. What exponent can I put on 5 to give me 125? I put 3 on that exponent of 5. Okay, so my log is 5. But your calculator can't do this. It can only do logs with a base of 10. And because we deal mostly with bases of 10, we don't even write this number on there because we assume that if there's no number like 5 on there, that it's going to be the log of 10. It's kind of like having square root of 9. You don't put the 2 on there. You assume if there's not a 3 or a 4 or something that it is a 2. It's the same with logarithms. If there is nothing there, it's assumed to be a 10. Okay? And so log of 100, you would say, what number can I put on 10, the assumed 10, to give me 100? And that would be 2. Alright, Ln is basically Ln, or no, let me write this different. Let's write it in this form first. Log of 2.71828182885, going on and on and on and on forever. Alright, so if we're dealing with logs, we're dealing with a base 10. If we have this number here, which is kind of like pi, it's just kind of this random looking decimal that goes on forever, if we have that, then that is our other option, and we write it as Ln rather than writing this whole thing. So Ln is actually this, log with a base other than 10, that's this number right there. Alright, so we're not going to get into the hows or anything else. We're just going to talk about how to do these. Alright, so let me show you something as far as the natural logarithm goes again. Alright, I said that we have the log and we have the Ln. Alright, that number, you know, that crazy number that I put on here, 2.71828, etc., 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 we're going to instead, like when we write pi, we write 3.1415, etc. Well, when we write this number, instead of using pi like we do here, we're going to use the letter E to represent that. So we don't have to write that long number. So that's what we write. And if you look at your calculator, you're going to have a button that looks like that. And then above it, it's going to have an E to the X power. Okay? And your log button is going to be a log, and it's going to have a 10 to the X power. Okay? These are anti-logs, these are logs, just so you know. And we'll get into some examples here, and that'll help you understand a little bit more about what's going on. So, let's try something. Take your calculator, and push your log key, and push 105. And you should get an answer like 2.021189299 for an answer. Okay, so what does that mean? That means that if we took 10 to this power, we'd get 105. Okay, so let's look at this logically. 10 squared is 100. 10 to the 2.02 da 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 is going to give us a number a little bit bigger than 100 because it's a little bit bigger than 10 squared, right? So 10 to this power equals 105. So when I take my calculator and I put log 105, it's given me the exponent to put on 10 that's going to give me 105. Okay? So what logarithms are basically are a way to find the variable when it's in the exponent position instead of somewhere else. So that problem right there is done with logarithms because I'm looking for the exponent x. So I use logarithms in order to find it. So what I do is I take this, I write it in logarithmic form. I'll put the 10 here, you don't necessarily have to. And I just type in log of 105, and that will give me the x that I'm looking for, the exponent. So using logarithms make it possible to find the x value when it's in the exponent. And back in the olden days before calculators, this was very, very helpful because there were some different methods you could use in order to find out what that exponent is. Alright, so a whole bunch of stuff here. Alright, so to confuse things even more, I'm going to jump into anti-logarithms. And again, I'm not going to go into a lot of detail, and we'll do some practice problems to kind of give you an idea of what's going on. But, well, let me give you an example, just again, of a logarithm. 10 to the x power equals 100. And we know that x is 2. 10 squared gives me 100. If I were to write that, that's an exponential form. If I were to write that in logarithmic form, log of 100 equals x. Okay? So, that is basically logarithms there. If we take our calculator and punch in log of 100, we're going to get 2 for an answer. Okay, so what is an anti-logarithm? An anti-logarithm is kind of like the inverse. It's kind of like if we want the square root of 9, we get a 3. If we want to go back to this number, we square it. So this is kind of the inverse. The square root of 9 is 3. If we square the 3, we get our number back here. So it's kind of, there's a relationship between 3 squared and the square root of 9. Just we're going back and forth. Same is true as far as logarithms and anti-logarithms are concerned. Alright, so a logarithm means we're trying to find the exponent here. Anti-logarithm means we're trying to find this number. So this is written as the logarithm. Alright, what number goes on 10 to give me 100? And anti-logarithm says, if I'm given this, what is my number here? Okay, so this number is the anti-logarithm. It goes back and gives me this number. So we're finding the answer rather than the exponent. Okay, so that's really the only thing that we're doing here. Alright, so let's try a couple of these. And we will do that on the next video since I'm running out of time. So hold that thought.